Mario asked me to try to relate my work to your work on post-growth, okay? So I thought that it could be interesting for you, my take on science for a post-growth society, which is what your work is about. I checked your website and I saw a lot of work on that starts or includes the word responsible. Okay, and that's precisely what I will try to do today with you. So to say that a post-growth society will need a lot of institutional, constitutional, legal changes, okay, and conceptual changes. And of course, science will be one of those things that will have to change for a post-growth society. And in that sense, the transition, because we are talking about transitions, right? The transition is from a paradigm of control and prediction. Is there any problem? No. Okay. The transition is from a paradigm of control and prediction to what we can call responsible anticipation. Is that the idea? No? So the role of science will no longer be to provide a kind of privileged input to society, to decision maker, to culture. That's based on the idea that we humans can control and can predict, can manage rationally through quantification. Okay, so that's the idea. So in order to do that, and as I said before we started recording, and is that COVID was quite important this couple of years for the diffusion of post-normal science. So why you use COVID? Because most of you, this is something that touches all of us, okay? So therefore, we are all experts in COVID at this time. So let me start. And if you have problems with the presentation, let me know. This is a recent, as you see from May, an article in one of the main Italian newspapers, Corriere della Sera, and it's an interview to an immunologist, a member of committees of advice and all that, who says that science has to apologize to the Italian people because it didn't speak with one voice. Okay? So the apology is because science, in the case of COVID, was not able to speak with one voice. Okay, so the question for you for reflection is the following. Can and should science speak with one voice? Okay, you'll remember that. My second slide. This is from another important person, David Spiegelhalter, who is an expert on risks and statistics and epidemiology. He's member of the expert group advising the British government on COVID. No? And as you see, this is from September. And what David says is that he doesn't like this phrase that was used practically for all governments. Oh, we follow the science, right? We follow the science. And he said he actually doesn't like that expression because it seems that, first of all, that the same science produces dramatically different opinions among scientists. So in a sense, it's responding to the previous immunologists about, well, we have different opinions, and not only that, but different opinions are then articulated in different strategies about what to do. And the question is, that I leave it for you from this, from this slide is, if you know the science, do you do what to do? Okay, so that's the question from this. And now, and this is, as you see, is also from September, and for important person. I mean, perhaps you know about John Ioannidis. John Ioannidis, it was not only important in terms of epidemiology and, in Stanford, but he also published a lot of papers showing what were the mistakes, why much of research is false, and much of the publication. They created this movement about retraction and all that type of things, right? You can see that, so he is in a situation, because he was criticized about his position in relation to COVID and fundamental freedoms, everything that mattered was affected, scientists interpreting science, and you can see, and all the controversies, some civil and not civil, that were among epidemiologists, where he also was accused of flawed research. And so you can go if you are interested. But my point is that the title of this this article is "How the Pandemics is Changing the Norms of Science." Okay, so that's what I'm trying to concentrate now, just in order to introduce this idea about why we need a different type of science if we are going to talk about a post-growth society. And are you familiar with the norms of science? It's just, if someone is familiar, please raise your hand. Okay, Mario. Okay. I don't know your name, but yes, I saw two hands. Okay, norms of science takes us back to Robert Merton, who was a sociologist of science. And in the early 40s, he wrote this article about science and technology in a democratic order, and he established what was called the norms of science. These were known as with the acronym of CUDOS, okay, CUDOS. And here you can see that it's all about communality, which is ironic because in the original he called it communism, but of course he changed it at that time. Then universalism, you can see that. The point I want you to realize is that we are in 42, in the middle of the Second World War. Okay? So there was a war, not only a military war, but also an ideological war against two enemies. On one hand, Nazi Germany, and on the other, the Soviet Union. And the idea is, and Merton and Karl Popper, I think most of you have heard about Karl Popper in relation to science, argue that only in a liberal democracy it is possible to do science. Okay? And they gave the examples that we can talk about later, but for example, in Nazi Germany, the idea of German physics against the Jewish physics of Einstein and all the others. And in the Soviet Union, it was the case of Lysenko. Probably those who are interested in agriculture will, remember very well the affair of Lysenko, right? So let's see how I go to the next one. And so they argue that only and remember this, the idea that science can only be done in an open society. And scientists and the community of science share these values that are expressed and synthesized in these norms. Let's see how I go to the next one, because I get only, can I get the next one? So we'll see. Someone can help me. No, yeah, I got it. Okay, here. Now, this is interesting because in the 1970s, a sociologist called Mitrov, Jan Mitrov. Do you know about Jan Mitrov? Those who know about, okay. Jan Mitrov, sociologist, went to NASA, and interviewed the scientists working at the Apollo moon project. And what he found is what were called the Mitrov's counter norms. And as you see, for each of the elements of Merton, he introduces exactly the opposite. Okay? Is that clear for everybody? So you have solitary, isolated scientists instead of community, particularism instead of universalism, interested instead of disinterested, and organized dogmatism instead of skepticism. Okay, so now what happened in 30 years? That from those norms that were associated to liberal democracy and doing science changed into something that is exactly the opposite. And here is where I come in and say how this is related to growth. Okay, and so, and here it is. I think many of you will be familiar with this report from Vannevar Bush that was called Science, the Endless Frontier. And this is a report that was produced, ordered by the President of the US after the Second World War, and it is based on the support that science gave to the military objective of winning the war, okay? And there are many things, but some of it, I think you're familiar. It's not only the bomb, okay? But also, for example, computers and cryptography, no? Turing, although I remember Alan Turing. But not only that, two logicians, mathematicians, Wiener and von Neumann invented queuing theory and logistics and what it was called decision analysis, later operational research. All this was an important input to the war effort. So here it is, in 45, science and science-based technology becomes the basis of the economy for growth and employment. Okay, so it's the main engine of production growth. So it is consistent with the ideas that were around in the free world, as it was called after the Second World War, about growth, employment, the economy, and the rest. So it's just, so so you have it here, the three things together: liberal democracy, science, and economic growth. An idea about what makes the economy work. It's science and science-based technology. And together with this comes the idea about growth in science. It's the moment where universities multiply. Okay, is that clear? So you have from small, when it was based in Europe, science mainly around a few universities where everybody knew each other. In physics, in biology, they knew each other, you know. And from at the time where you have this growth, exponential growth, industrialization of science, corresponding to the ideal of science as an engine of production and economy and jobs, okay, and progress. So that is exactly how you read it. Now, I don't have a slide, but it's interesting that that works, this idea, until the 60s. Very short run. In the 60s, the mood changes. And you start to see a critique concentrated on, we can call, the pathologies of growth. Okay, and probably you're familiar with Thomas Kuhn's book, The Structure of Scientific Revolutions, where he actually criticizes Popper's idea about progress in science. Okay, but not only that, in the same year, and probably you are more familiar with this, Rachel Carson publishes her Silent Spring. Again, about the pathologies of technoscience in agriculture, right? But those things were introduced precisely with the idea of growth. Growth in agriculture, growth in employment, growth in food, and etc. So you have all these two things that are important, showing a change in the mood, where progress is no longer looked as in an uncritical way. Okay, now the other book, which is important and relates to our subject about science and growth, is Derek Price's book called Little Science, Big Science, 1963. If you want, later I can give you the references, but it is important because what Derek Price saw was that the exponential growth of science and science publications and science community was going to create a problem of quality in science. And you are all in an academic media, and you know about the measures of quality, H-index, impact factor, and all. Derek Price is the father of all those quantitative indicators of excellence. And the argument is quite clear. If I don't know the people of the community, I have to find some more formal ways of evaluating the production, right? So from something that was informal because everybody knew each other to a situation where nobody knows each other. And you have this incredible growth in universities and in research, doing it in different areas, not only universities, but research laboratories, private enterprise, and so on and so forth. All of them trying to publish and publishing millions of papers. So you have a proliferation of journals, you have a proliferation of articles, etc., etc., etc. You have patents and all that. You have to create, Derek Price said, a system to judge the quality and see which one is reliable knowledge, legitimate knowledge from the other, right? So this is the very strong relation between precisely growth and the problems of and the corruption of quality in science. Okay, this is a very important point. And you can say it's the same thing with economy. When it grows, you'll have problems. You know, when there is no limit to this growth, really, you're in trouble. And this is precisely what Derek Price saw in relation to science. Just to give you information for those in the UK or whatever, the Royal Society award on quality in science and so on is called Derek Price. Okay. And it's interesting because in his first publication of that book I mentioned, one of the prefaces was by Robert Merton. Okay, so immediately after that book, it was created the citation index. Now, are we okay? Good. I'm looking at the time, don't worry. And now, okay, let's go back to COVID. And here you have an editorial from the British Medical Journal, and that was 2020, and it is about uncertainty. And the idea that is uncertainty dangerous? People will lose trust in science or credibility in government action if you recognize and acknowledge uncertainty. Well, this editorial says is exactly the opposite. And what is interesting from 2 years ago is it says the idea of game-changing pronouncements. And immediately you can think about vaccine. And the idea, it is a game-changing situation having vaccine. And this idea is quite important from a political point of view. And what they say, certitude is the obverse, the opposite of knowledge. Okay, this is very strong language. But not only that, and here you see mentions merchant of doubt. And you know the book by Conway and Oreskes about the merchants of doubt, but there are other books. And you know David Michael's book about the fabrication of uncertainty by big pharma and agrobusiness. Okay, so remember, so the idea of uncertainty and trust. And the question, and is uncertainty a scientific problem or a political one? Okay, that's the question. Next. And here, another from Nature point in relation to uncertainty. You know, the typical way of handling things, and here in the European Commission, you have these expert groups, no? So you have a political, practical problem that involves somehow knowledge, so you call an expert group, you know. It has even what it called comitology. Inside, it's called comitology. What are the role of those committees of experts? No, I participate in many of them. And people try to do well. And here the EPA, the US Environmental Protection Agency, was asked to, to talk about clean air, which seems not rocket science. I mean, it's not like COVID. Everybody knows about clean air, air contamination, pollution, it seems. And they found that high uncertainties in terms of quantification. So even what we can call a simple problem, okay, resulted in something that it was difficult then to operationalize into policy options because of the high uncertainty. But what's interesting is the idea that I questioned it before, that uncertainty is not a scientific problem, but a political one. Why I'm saying that? Because uncertainty is the element that makes science move. And science and science-based technology are the elements that create uncertainty today, right? And it is an incentive to do research. So here you have a bad and good uncertainty. The bad uncertainty is that one that is fabricated to stop regulation or change. The good uncertainty is that it is produced because of the growing complexity of the research enterprise. Okay, let me see. And here I have David Michaels. This is quite, as you see, that's from 2005. And doubt is their product. No, that was even much before. It's even 15 years before to Oreskes and Conway. No, and the idea is about big pharma and tobacco. How they commission research in order to create uncertainty. No. And I would say, well, I will stop, but this is an element too. If you want, later I can send you the PowerPoint presentation so you have it. Now, why is it a political problem and not a scientific one? Well, because this diagram illustrates what is called the main problem-solving strategy of the modern state. You have a practical political problem, you translate it into a techno-scientific problem, you solve the techno-scientific problem, and then you say, we have solved the political problem. Okay? That's how it works. And I don't have time to go. Next time, if you are interested, I can develop this idea too, and from where it comes, how it relates, and most of it relates also to the development of statistics, no? And you know, statistics has this state, no? Nobody thinks about etymologies anymore, but you know, statistics was created the science of the state. Okay, so we can talk about this another time. Let me see. And here we are. What we see is that translation from a practical political problem, a problem of governance, we call it, is reduced to or translated into techno-scientific problem that usually gives you a kind of numerical or quantitative prediction that enables you to manage rationally. Okay? Now, what is interesting is that this reduction I mentioned here before has worked quite well, in the sense that it helped to develop science, technology, and our institution of governance, no? Including ideas about democracy, including ideas about human rights and all the rest. But also it was ambiguous because it enabled small European countries to become imperial or colonial powers. Okay, so you have always this ambiguity, but it worked well, we can say. But this was because problems were not conceived as complex, but as simple. And another time I will show how science was developed on the idea of simplicity or even complication, but not complexity. I don't know, I think I will explain briefly what I mean by complexity. Complexity is when you have a plurality of legitimate perspectives that cannot be reduced to a single perspective. Okay? And so, what complexity means, if you want to remember one thing, is ambiguity. Okay? Do you know, to distinguish what is vague, is ambiguous? A vague is a fuzzy boundary. Ambiguous is when you have a multiplicity of meanings, right? So it doesn't work, this reduction, because here it is assumed that there is a one-to-one relation. One problem to reduce, to solve. But in the case where you have complexity, you have one practical political problem to many possible knowledge interpretations of problems to solve. Right? And if you think about this, the pandemic, think about climate, think about biodiversity loss, ecosystems collapse, all those, the transition to sustainability or to a post-growth society are complex problems. There is a plurality of legitimate perspectives on how to do it and what is the problem, what could be a solution, what could be the transition. Is that okay? Now, and I will, this will be my last, I have others, but I don't want to go beyond the time so we can have a nice conversation, is when you are in a complex situation like the ones I mentioned, and you can add as many as you want. I saw on your website you are dealing with many type of problems that have certain features that are not the features of modern disciplinary science. Okay? Now, for two reasons. One is that this translation problem-solving strategy in simplicity is based on two, some of you perhaps are economists, will understand the word externalities. What disciplinary science has done is to externalize two things. The first is the context. And the second is our body, our person. Is that clear? In modern science, there is no room for context. There is no room for our bodies. Another time I can explain, but that comes from Galileo, actually. He called them primary and secondary qualities. Secondary qualities are us, our perception, our senses, our passion, okay? Those things have to be externalized for science to work and be measurable. Okay, now, but when we are aware and we are now framing problems with other features, which we call the post-normal features, and we call the mantra, it's here, and it is from paper mentioned by Mario from '93, but we started working on this. The first paper in which the diagram and the conditions appear is from the early '80s, so it's 40 years now. And this idea that facts are uncertain, values are in dispute, the stakes are high, and the decisions are urgent. I think each of you can give example, illustrate each of these features in problems, as I say, problems of sustainability, climate, whatever, and also the pandemic. And what we argue is that in this situation, we have to put into bracket the ideal of truth. Truth is interesting mathematically and philosophically. And I can talk to you days, you know, better if we sit with a bottle of wine and we talk about truth and all the rest. No, I'm interested because I was a mathematician, a logician starting with. But in this situation, we cannot afford it. Okay? We cannot afford it. So what we argue that we have to shift to quality, which is precisely the problem that Derek Price highlighted in relation to growing science, exponential growth. But not only that, quality is also highlighted in the idea of economic growth. And I can talk about that because total quality control was created by Edward Deming in relation to the production of cars in Detroit. And they didn't want to know. So when Edward Deming went to Japan, went to Toyota and all that and told them about his idea, they say, well, that's exactly what we want. And then you can discuss about the cultural difference between one type of growth and another type of paternalistic growth. Okay, so what we argue is that the idea of quality becomes central. And what is the main difference? And I'm finishing now. That the main difference is that quality is fitness for purpose. So we have to determine what is the purpose of the production of knowledge or knowledge inputs, and who decides what is the purpose. And we argue that there is society at large, an extended community of people, and it's a process in which a society or community decides what is the purpose. How do we define the problem? What are the tools? How are we going to do it? And we call that extended peer communities. And well, this is more or less what I had. I had other things, but probably this is enough for starting a conversation. Thank you. I'll stop. Yeah. Okay.
Wow, thank you very much, Silvio. Yeah, you put on the table many things. Some of it is quite well known and discussed here in the group. Some is not. No, all the discourse about science as modern science as a manifestation of this ideology of growth and progress, and somehow, yeah, you put everything in place in the sense that you cannot really distinguish between this Western modernity project, science, growth, power, imperialism, and we are also interested in colonialism. So everything is like after your speech is like getting in the right place, no? Okay, so more than question, I don't have questions. So, well, I have many comments and many questions, potential questions, but I want our younger friends to comment because here we have a very diverse group of people. Some are coming from a more positivistic perspective, some are coming from STS, some are coming from humanities as well. I don't know if you have questions or you want to Silvio to explain certain aspects of the science.
Yes, I prefer if there are questions, then I can add something that more focused on the interest of the people, right? I heard someone
so maybe I can start
to say something. Oh no.
Okay, Javier.
Can you hear me?
Yes.
Thank you very much, Silvio. I really enjoyed the presentation. It was great. So I have a question to start with, because if I understand correctly, what you said is that it was the growth of science and the production of scientific knowledge that created uncertainty. And my question is, was it only that, Or does it also, like this uncertainty is also created by the type of problems that scientists are dealing with? Not only the amount of scientific knowledge being produced, but also like the different type of problems that we are dealing with, which are more global and more complex probably than they were maybe in previous centuries. I don't know, like just thought whether you could comment on that.
Yes, I didn't explain myself. I said that growth was related to the problem of quality, not the problem of uncertainty. Sorry if I didn't, it was not clear. So there was the question of growth has created the need to reevaluate ideas of quality. Uncertainty is a different thing altogether. And it relates precisely to the, okay, I will add two things I didn't say, but I had it in my slides. Anyway, the reason why modern science from the beginning, Descartes and Galileo mainly, have decided to externalize context and our person, our body, is precisely to eliminate uncertainty. So David Hume, for example, argued that if you look at the way they conceptualized the universe and nature, it was like a clock, a mechanical clock. There is no uncertainty, okay? So it's our looking and studying, analyzing the universe, nature, that introduces uncertainty through our perception senses, okay? And Hume argued that it is our passion, our interests, that creates uncertainty. So we need to separate ourselves. And from there comes the whole idea about value neutrality, its objectivity, etc., etc. It was a requirement in order to reduce complexity. So context and our body. But they were very well aware about what they were doing. Hume said that reason is and should be the slave of passion. So many philosophers and everybody has been discussing that phrase from Hume for a long time. But the idea that at the end of the day, your reason is determined by your passions. So they were well aware, but in order to do science, they had to make this simplification of complexity. Now, in relation to your question, and I will give you opportunity to the others, is you have to reduce complexity always. The problem is how do you do it? And our argument is that the reduction of complexity by externalizing context and our body doesn't work anymore. So the whole research is geared towards the idea is how do you find other ways to work with complexity? And when I said, and that relates to Mario's question when he asked me to make this short presentation, is the following. If you are no longer in a paradigm of control and prediction, you shift to a different situation in complexity, and the only certainty is error and failure. Okay, so this is a kind of meta theorem. The only certainty is that you'll fail and you'll make mistakes. It's exactly the opposite of control and prediction. And not only that, you pass from what economists and mainstream economics and mainstream science will call a situation where you can have a blueprint. It was called planification. Okay, have a blueprint about what to do. You can plan for 4, what was it? Soviet Union had the 5-year plans, also the European Commission and all that. They have the plans, for 4 years it was. You cannot have that. So you have to experiment. And here is the problem. It's a problem of legitimacy and credibility. How do you shift from a situation of blueprint, of prediction, of control, okay, on institutions that were created for that, bureaucracies that were created for that, a legal system that was created for that, a constitution that was created for that? How do you say, oh, we were not serious, now we have to change? Right? So the problem is not experimentation, it's not failure, it's not error, but how do you do it with credibility, with legitimacy? And that implies a process of society transformation. It's the same problem you have with growth and economy. You have to say, well, sorry, we cannot do it anymore. It's not so simple. There is a long tradition, there is a culture, there is institutions that were created for that. So this is why you have to create all the elements that will enable a transition. And I will add another element. I'm sorry, I am extending more, but I think this is an important point. One of the fundamental elements in modern science was the idea of responsibility. For Descartes, Galileo, Bacon, the idea was that if you do research and innovation, as it is called today, you are necessarily a good person, morally. So this idea that science and technology progress is linked to an idea of moral progress. Okay, that is fundamental. And so you see what I'm trying to say. If today the European Commission had this failed program on RRI, as it will call Responsible Research and Innovation. Why I call it fail? Because it didn't recognize that, as I said, for the creators of the modern state and modern science, research and innovation were always responsible. If you add responsible to research and innovation, you are flagging the fact that there is a lot of research and innovation that is not responsible. You see? You can do a post-structuralist analysis, BARTS and so on, about precisely when you add the responsible in front, you're in trouble already, because you're shifting, you are recognizing, that. So the second element is that is the aspect of responsible, is the aspect of morality. And this is very important, because at the end of the day, and I'll tell you as a philosopher of science, we can talk about that, all methods of science was based on a certain ethical and moral position. Without that, you don't have a methodology of science, okay? And I can justify that historically. So we have to say, and with these ideas of responsibility, ethics, morality, and so on, bring it back, that is not bring it, it's not introduce it, as many people think, but try to make explicit what is the ethical, that it is implicit in current science and other forms of knowledge production. And then discuss precisely what are those ethical bases. An important element of it, and relates that for me it's very important, but perhaps it has to do with my age, is the fact that I want it to be done in a non-violent way. So non-violence is a very important principle and commitment.
Silvio, sorry, we have a question from Joe and Sophia.
Enough.
Yeah, thank you so much. It was super interesting, and I'm not sure if it's a finally formulated question or more like a train of thought, but I guess this concept generally around like what is normal and what is not normal, or what is natural and what is not natural, right, is something that has historically been very much constructed by patriarchy and cis heteronormativity and different forms of domination. And so I kind of wondered how, you know, like kind of maybe as we move then towards like this post-normal science, knowledge production, different forms of knowledge, you know, taps into feminist and queering and crip perspectives, you know, that have kind of like experienced, I suppose, these different forms of hierarchy of what is the normal and what is unnatural or natural.
Absolutely great question. I was using normal as a label associated with this idea of kun, and I can talk about this a bit more and why post-normal. But you're absolutely right, and that is from the beginning. You know, you mentioned normal. Normal is associated to a certain way. It's related precisely to statistics. No, at the creation of the modern state and a certain way of running bureaucratically the institutions. So you're absolutely right. But even you can go further back and talk about what is rational, okay, and what is not rational. And if you ask the mathematician what is rational, he would say a number that can be expressed as a, you know, n over m, as a ratio, because that's the origin. And it is interesting, and is that when you have root 2, we call it irrational. So there was this shift from reason to rational, and irrationality that expressed the most important element of rationality, because the theorem that shows that. There's a strong relation between, between post-normal science and feminist epistemology. And that is, for example, Sandra Harding's or Donna Haraway's idea about strong objectivity, right? Which opposes the idea of a view from nowhere. Sorry, Sophia.
Thank you.
Hi, thank you so much. I'm a historian, and I have a sort of a reflection and then a left field question. And the reflection is just about the co-optation of this idea of uncertainty. So last night I went to a networking event for film, and I met a group of people that have just worked on this big promotional material for vertical helicopters, vertical aerospace. And they've developed these flying taxis, which allegedly have zero emissions, super fast charging batteries, and make less noise than a washing machine. And they're presented as sustainable solutions. And their consultant, the way he responded to my questions about these aircraft chimes a bit with your talk. I think he framed technological development in terms of post-normal science. So he was like, we have to start somewhere. This is uncertain. Science is uncertain. and presented this tech as an expedition into that uncertainty, complexity, to see what can be done. And it was just interesting to me that this idea of uncertainty is being adapted to basically legitimize new projects, the idea that these companies are taking responsibility for solving problems. So that was just my reflection, but maybe that's very normal to other people that work in science and tech.
No. In the 40, I can send you when Andy Sterling organized this conference before COVID on the politics of uncertainty. I have a clip of 10 minutes, which I can send you. Precisely how this idea of uncertainty has changed over time. And I can say today, just to have a quick answer to your question, is that everybody has learned how to play the uncertainty game. Okay, so it can be used to stop, it can be used to promote, and this is quite interesting. The same way as you talk about disruption, no, disruptive technologies and all that, you can legitimize, so you can use uncertainty. This is why in post-normal science, although we start from a discussion, an analysis, a way of coping with uncertainty and complexity, we move to this idea of quality and not uncertainty. Okay, which is, and we try to establish by clear in an operational way how what do we mean by quality and how do you go about it. So you leave us outside because uncertainty is something that, as I say, today is used strategically. It has been politicized necessarily, and everybody recognizes. Even they talked about known unknowns and unknown unknowns. So we have moved to a different level of no longer uncertainty, contradictory certainties, but also a situation of profound ignorance, you could say. And you see that in COVID and all the other situations. So thank you.
Can I ask another question? Sorry, does anyone else have a question? Oh. So my PhD was about the application of fixed normalizing medical rules to space in urban planning in the 19th century. And during this period, science was conceptualized and allegorized as a woman, so one figure that would naturally have one voice. And this was part of making science palatable. And it made me wonder about whether post-normal science can be or would be embodied as a conceptual figure, and how you could present post-normal science to fit in with the tradition of conceptualizing science as a human. So I guess, what is the human face of post-normal science?
Well, that's a very challenging question, but yes, you can do a kind of genealogy of post-normal science. Okay, so post-normal science doesn't appear suddenly because we were sitting with Jerry at Leeds University in the philosophy department just talking. No, it appears as a continuity with other forms of changes that you can trace quite clearly. Now, but going to I think the face of post-normal science today is in the problems, the main challenges we see for us, for humanity today. And now we have the pandemic, which will stay with us for a long time, and other pandemics to come. But it's climate, is as I say, ecosystem health, it is biodiversity, transition to sustainability. This is the actual face of post-normal science. And what I mean by that is the face is conflict. Okay, so is the conflict among people trying to face the challenges, sometimes in very difficult situations. So for us, the face, as in my view today, the face of science is on those communities who are making knowledge, okay, in order to do things that the state and the institutions are no longer doing. Okay, it was the same with education and health. You know, when the state retreats on education, health, and all that, that space has to be occupied. Okay, and it is the same with knowledge production. When those institutions that are supposed to produce useful knowledge to solve practical, real problems by people are not doing it. No, that's the face of post-normal science.
Thanks a lot, Silvio. Does anybody have more question? So maybe I have last question because we have another presentation in 15 minutes, but I really want to ask you something like very direct to the point. One of the things that people say, and this is very common, and I'm pretty sure that you came across very similar question or criticism. When I present this idea of standard peer review or collective decision making, is okay, but there are two main problems. One is that this is unfeasible because people don't know things, so they are not able to decide about complex things. So, for example, I gave some of my lecture here in the University of Vigo, and economists or people in management, they always say, yes, but imagine that you want to involve here in Vigo fishermen community. They will tell you we have to fish more and you have to build more building on the coast. They don't know, And so how do you normally reply to this? And the second point is that how do you practically do like proper engagement, and how do you transform into practices, like real practices, solving real problems? Now, maybe not the big problems like the super big problems like the COVID, but how we can create mechanism in which we can use post-normal science to solve practical complex problems. No, like for example, here in Galicia we have a problem of fishing. Conflicts on fishing.
Also in Norway, yes.
We have the problem of Ence, which is the factory of paper.
Yes.
Pontevedra,
Yeah.
and there is totally polarization of the conflicts. You have workers against the city council. That is like.
Okay. There are different elements, and I don't have the time because you have a time limit, but let me start what I hope it's a conversation of all these things. The first is that the people don't know this is rubbish, and it has been shown historically. Most of the problem, Sophia is a historian, most of the challenges that humanity have faced in the past have been solved by people's knowledge and not by science. And I can do a course. I mean, the colonial expansion of Europe was almost impossible to think about. Navigation, commerce, and all that was impossible without a watchmaker, clockmaker from Yorkshire called Harrison. Okay? And that's a problem that was Newton couldn't solve, and the Royal Society couldn't know. I invite you all, next time you go to London, go to the Greenwich Observatory to see the Harrison clock. Okay? And not only that, I can give you millions. Example, starting from Italy, the dome of the Florence, cathedral, done by Brunelleschi solving the equations. Everybody talks about that as knowing that and not knowing how. What they don't know is a generation of craftsmen have been working since then to keep it in place. So let's start by correcting who knows and who doesn't know. Which scientist or economist knows how to work in complexity? Okay, I would say we know. People know, because they have to do it all the time. I finished now a paper with some colleagues in Bergen precisely about how to introduce tacit knowledge into in the extended peer communities and so on and so forth. So we are working, creating. Lastly, because I see your time is right, we are with, as I say, with other people, are developing in practice how extended peer communities can be operationalized. But remember that that has not been done before, okay? And when it has been done, it had the opposition of the state and other institutions. The European Commission promoted with me when I started, it was precisely for that in relation to risks, the Seveso directive, participation. But participation was like painted. It was a veneer on top of institutions that were not prepared for participation. So the first thing we have to do is to discuss precisely that. How you make participation and engagement serious. Now my former student and colleague then, Angela Pereira, has created a competence center at the Joint Research Center on engagement, where we are trying to develop that seriously. Okay, so I invite you to look at that. The idea is we have to change the institution, the legal system, the constitutional system, in order to accommodate engagement. Okay, so, and I'm going to finish by saying that the extended peer communities and post-normal science is not a prediction. It's a commitment. It's a bet that we can do it. Okay, Gramsci said that history teaches, but it has no students. Okay, Antonio Gramsci, I think that most of you are familiar. We have to show that he was wrong. It's a bet. We are betting that this is possible in a fractured, polarized society where violence is always very close. Okay, if we cannot bet on that, why are we talking about post-growth society? Okay, why? So that's a first step, and at the same time we have to illustrate this. It can be done in everywhere we can with small projects. You say I think so. I was invited to Asturias when they had the problem of the salmon. No. The salmon in Asturias is the one who has to swim more coming from Canada, or whatever. And I was invited by López Cerezo, another philosopher, with the fishermen and institutions in order how to facilitate all the problems that the salmon had. And as you know, the Campano is an institution, no, in Spain, and it has not only in Asturias. And that was an attempt to introduce these ideas of extended peer community, where fishermen, anglers, all the people in charge of the rivers and try to contribute to make it happen, because it had some important political symbolic element. So I don't know why. If in Norway we recognize that the fishermen have knowledge, I don't know why in Galicia no. Or in Canada, okay? Thank you.
Okay. No, gracias a ti. Thank you very much to you. Okay, so we must finish because we have Elisa presentation, but this
Gracias.
is for me. This is just a starting point of our engagement with your work, and really hope.
Well, you know where to find me, and Mario has my email, has everything. If you want anything, ask me question. I answer all the emails I receive. Okay.
Yes, and I was taking notes, and probably, well, I will contact you because maybe I have a couple of ideas of paper that we can write with you, or with your advices, or with your guidance as well, especially on this idea of growth in science, because one of the work package of our project is also about a science institution, and how science is being like increasingly co-opted by this ideology of growth, or actually, as you show, was born also with this idea of like a moral kind of commitment. So it's the non-neutrality of science. And of course, I would be delighted to have you in spring or in summer, because we have the best white wine in Europe, you know.
No. In Friuli, in the Collio, is the best white wine in the world. So, but I will be happy when I am in Catalonia, where I have my summer residence, where I live 6 months a year.
You can take the high-speed train with Mario if you like, and come here.
Okay, I thank you very much. It was great, and hope to keep in touch.